is the 13th. So the opener today is just a little bit of a review of everything that we've done so far, third triad. So let's take a look at the first equation here. Looking at this, what kind of equation is this?
A square.
A square. So when you're like, ooh, how do I do this? I don't remember. Look at your notes. The whole reason why I had you organize them notes is so you can use them on your quiz or on your upcoming final to help you remember what to do. So on your notes, it would be solving equations with squares. So according to your notes, when we're solving an equation with squares, we're going to circle our variable, we're going to draw our line of equality. Then what is the other step I have to do? Box it. I'm going to box what's being squared. That's my visual cue that if there's anything on the outside of that box that's on the same side as that square, I need to get rid of it. Well, in this case, there's none. It's just the a squared. So I don't have to worry about getting it by itself because it is. So now I need to get rid of the square. So how do I get rid of a square? I square root it. If I square root one side, that's right. So my square and square root will cancel out. So on my left side, I now just have an a. Then on my right side, the square root of 12 will not be a perfect square. So this is where you're going to have to do the factor tree. You're going to have to simplify the square root of 12. Remember all that? So what are two factors or two numbers you can multiply together to get 12? And remember, I'm going to circle my 2 because it's prime, and then I'm going to factor 6. I heard it. Somebody just say it again. 2 and 3. Those are prime numbers, so I factor them. I come up, I write these prime numbers in order from left to right under my square root. So 2 times 2 times 3. Now, from here, what do I do with my factor pairs? I circle them, and then they become a single number in the, or as the coefficient, the outside number. And then whatever I have left over on the inside stays on the inside. So just like that. So the square root of 12 in simplest form is going to be a, excuse me guys, a equals 2 square root 3.
I know.
So why is
Yeah, why you just didn't do 3 times 4? Yeah, no.
or 12 times 12?
Remember, when you do factors, you can use various things. So think about it. 5 times 10. Are there only 2 factors for 5 times 10? Are there only 2 factors for 5 times 10? No. I could use 5 and 10. I could use 2 and 25. I could use various things. But you're going to end up with the same prime numbers. So it doesn't matter if you use 3 and 4 and then you use 2 and 2. That's fine as well. You're going to end up with the exact same answer. You're going to end up with the same factors.
Okay, I'm going to talk about that, but I know that. I got 6 for that.
I'm talking about the M's.
I did not get that. I got 6.
How did you get 6?
Because basically, I square rooted and I was like, oh, 6. And 2 times.
Okay, so the square root of a number is that number times itself. So if you say it's 6, well, what's 6 squared? 6 times 6 will be 36. There is no number that you can multiply by itself to get to 12.
Oh.
Okay?
I have a question. So, how do you, you get to, when you do that, it's like taking out the square. So, how you do that now? Priming the number.
What's that?
Like 12, then you factor the...
How did I know that it wasn't a perfect square?
Yeah.
Okay, so do you guys remember when we did our perfect square notes? Long time. That was second triad. You have a button on your calculator. So if you don't know that 12 is not a perfect square, use your calculator. Type in the square root of 12. You're going to get some crazy decimal. So then that's your indication that 12 is not a perfect square.
Wait, which one is it?
Not 12 squared, the square root. So you have to put that square root little button. You have to hit the second button. Do you get a crazy decimal? So basically, to get rid of the 3, I divided each side by 3, rewrote my left side, and then simplified 6 divided by 3. Now, is my square root by itself? Yes. If my square root is by itself, I now need to get rid of the square root sign.
Square.
Square it. If I square one side,
Square.
I square the other. So square and square root cancel. So on my left side, I can bring down just my 3b minus 2. And then on my right side, I need to take 2 squared, which is 2 times 2. 4. Then from here, I just have a two-step equation. I solve as usual. So how do I get the b by itself?
3b equals 6. Divide by 3.
So then to get the b by itself, Rihanna said we're going to divide by 3. So then 6 divided by 3 is going to be
2.
okay. All right, let's take a look at the third one here. So the third one is solving equations with variables in multiple locations, and that's going to be the part 2. The reason why that you're going to know it's the part 2 is because it has variables on the left side of the equation and variables on the right side of the equation.
Well, do we have to, like, for the final, for the check solution, is that extra credit?
Yes. Okay, sorry, my network is messing up on me, you guys. It's not working all that well today. Okay, sorry. So, draw a line of equality. Circle all of our variables. I will take off points every time you don't circle your variables. I have been pretty lenient on quizzes and only taking off 1 point, but when I go to grade your exam on Monday, each problem that you do not have that circled, I will take off 1 point per problem. Okay? Circle your variables. All right, now, when I'm solving equations with variables in multiple locations, the first thing I do is what? If I can.
Right, Rose?
Distribute. So we're going to distribute with the 3. So what's 3 times d?
3D.
Then 3 times what type of 4?
Positive.
Positive 4. So it's going to be 3 times 4 is
12.
positive 12. Then what do I bring on down?
The negative 5b.
Then my equal sign. Then I look on my right side. This one's kind of tricky. We haven't really done a problem like this. Can I distribute on my right side?
Yes.
Yes. What am I going to distribute with?
The
The negative sign. Okay? So I'm going to bring that 4 down. I can't do anything with it. But this negative here, I could take it and multiply it by each number or each term inside the parentheses. It would basically be one way of thinking of it. Instead of just a negative, it'd be a negative 1. So what's negative 1 times d? Or negative times a d? What type of d? Negative d. Then what's a negative times a positive 9? Negative 9. Now again, anytime I have a variable by itself, what can I put in front of it to give it a number value?
1.
A 1. So I'm going to throw a 1 in front of that. After I distribute, I then go back to my left side and try to do what if I can?
combining like terms.
You both had trouble spitting that out. Combining like terms. So what are my like terms on my left?
3D and negative 5D.
Thank you for adding that negative in there. 3D minus 5D. So what's 3 minus 5?
Negative 2.
Negative 2. And what's my variable that goes with it?
D.
And then what do I bring down that I did not use?
Plus 12.
I put in my equal sign. On my right side, do I have anything that has the variable d with it besides the negative 1d?
No.
No. So I'm first going to bring down my negative 1d because I like to put my variables down first. It just keeps my work easier to read, easier to solve. So then what are my like terms on this one?
4 and negative 9.
So what's 4 minus 9?
Minus 5.
Minus 5 or negative 5? Okay. So I've distributed. I've combined like terms. Now what do I do?
Minus 12.
Nope, not yet. Not yet.
Plus 5.
I need to get my variables to the same side. So I pick on the little guy. So what's the little guy variable here?
It's -1.
Negative 2.
Which one is it?
Negative 2.
-1.
It's negative 1.
Think about it like money. Always think of math like money. You got it, but listen.
Oh, yeah, it is.
Which is less? If you owed me -2 or -1, which is going to be less money-wise?
Negative 2.
-2. So -2 is going to be your little guy. It's further away from 0 on the number line, so it's smaller. Rihanna, would you rather owe me $2 or $1? Because it's more, right? Yeah, so -2 will be your little guy. So we're going to, how do we get rid of that -2?
Plus.
Plus 2. D, right? So if I add 2D to one side, I add 2D to the other. So on my left side, it cancels. I bring down my 12 equals, what's -1D plus 2D? D. Could I put a 1 in front of it? Yeah, why wouldn't I want to here? Yeah, extra work. And then what else do I bring down on my right side?
-5.
What kind of equation do I have now?
One step
One
equation.
step.
And how do I get the D by itself?
Plus 5.
So my left side simplified, it's,
17 equals D.
and my right side I just bring down the D. Now what if you left that 1 in there?
Yeah, no, we gotta.
We would have to divide by 1.
Yeah.
So we get the same answer.
Yep. So that's why we just get rid of it. Any questions on that one? I need my water. All right, let's take a look at the last one here. It's just on the other side of my computer. Thank you. So this is what it shows on my screen, and that's what it's showing on there. There we go. Okay. So Rihanna asked a question a second ago. Do you guys have to check the solution on your exam? Sorry, Darius did. So he must have asked it in a very feminine voice. I don't know. Sorry. So I'm teasing. You don't have to check it. But if you know how, I recommend doing it. It's extra credit. If you try it and you get it wrong, I will not count it against you. Okay? So let's look at our equation. This equation here is just a multi-step equation. You can actually solve this in 2 different ways. You can solve it by using PEMDAS backwards, or you can solve it using distributive property, and then PEMDAS backwards. So, which would you guys rather do? Distribute or just use PEMDAS backwards from the get-go?
Distribute.
I do too. I like to distribute. All right, what am I distributing here? What number?
3.
3. So 3 times what?
2.
2.
What?
60.
Okay. Then 3 times what?
3 times -5, that's -15.
Thank you for saying -5. And then what do I bring down? And then on my right side, I just bring down my 0. It's already in simplest form. So now how many steps do I have to do?
3 steps.
3 steps. Ah, good. All right, Deontay, what are my like terms here? No. -15 and, okay, so what's -15 minus 3?
-15.
And what else do I bring down?
6
Equals, okay? Now how many equation steps do I have? So what do I get rid of next?
plus 18.
Okay, what do I bring down on my left
16.
and on my right?
18.
Okay, how do I get the E by itself?
Divide by 6 and it equals, oh, it equals 3.
That's right, E equals 3. Well, I think you're right. We're going to find out by checking it. Okay.
You have to.
So, when you check your solution, you just use substitution. So substitution means that every time I see that variable E, what do I substitute? What number do I substitute for it? Okay, so I'm going to write 3, parentheses, 2. What do I substitute? Do I just put it like this? There you go.
Plus 1.
Minus 5 and parentheses minus 3 equals 0. So I'm going to draw my line just to kind of keep my sides separate here. Now, can I distribute this outside 3?
No.
No, because you can't distribute when there's 2 numbers right here. So I'm going to have to solve this by using order of operation. According to order of operations, what's the first thing I need to work? The first area I need to start working this problem.
3. Wait.
What's order of operations? What mnemonic device do you guys use for order of operations? How do you know what to do first when you're working a long math problem that doesn't have variables in? PEMDAS, okay? So parentheses, P stands for parentheses. Do we have a set of parentheses here? Yes. So we're going to work within this set of parentheses first. So what do I do within this set of parentheses? So what's 2? Which is?
6.
Okay. I'm just going to cross that out so I don't have to write more steps. So now I still have my parentheses up, right? What's 6 minus 5 then? So when I bring that 1 down, what do I have to still keep around it? Parentheses. And then I'm going to bring that 3, because it's 3 times whatever that answer in the parentheses was. So 3 times 1 minus 3, and then we still have equals 0. Now I did my parentheses. For PEMDAS, the next one is E, exponents. Do I have any exponents? Nah. So then I go to my M, multiplication. Do I have any multiplication?
Yes.
Yeah, what?
3 times 1.
Which is?
3.
Okay. So then I just drop down my minus 3. Now what do I do?
3 minus 3 is 0.
Okay, so then I put in my 0. So then do I end up with the same number on each side of the line of equality?
Yes, you do.
Yes. So if that's true, then I put a check mark. Now, what if I know I checked my solution correctly? What if I know with beyond a doubt my solution that I checked was correct? But I didn't come up with the same number on each side of the line of equality. What does that say about the answer that I got? It's wrong. All right, any questions on this? Okay, we're going to stop.